Hello, everyone. I'm Chiara, an Android developer relation engineer working at Google. Thanks for coming to my talk. And by the way, sorry we are a couple of minutes late, but those wonderful people helped me to set up the presentation. So I'm here to help you to get your Android app into your user breeze by creating modern and expressive Wear OS experiences. So in this talk, we will learn how to use the modern design and unique capabilities of Wear OS to give your users quick access to their favorite features. I will show you the newest API to build modern and expressive apps and tiles by using Material3 Expressive for Wear OS. So let's start with Wear OS apps. Before I dive into code, I want to show you our latest design updates. At Google I/O 2025, we presented Material3 Expressive, the new Android material design update. Material3 Expressive is a design system focused on deep personalization, enhanced accessibility, fluid motion, and adaptive layouts for all screen sizes, offering a more vibrant and expressive user experiences. So now, Material3 Expressive Design is also available on Wear OS, both for apps and tiles, allowing a great level of expression to meet user demands for experiences that are modern, relevant, and distinct. So Material3 Expressive is available to developers to use via the Compose for Wear OS Material 3 version, which is now 1.5. So if you have an existing app on Wear OS, migrating to Material 3 has many advantages. For example, fluid motion, shape morphing, and more themed colors with support for dynamic theming. Best of all, you can rely on Compose components for the migrations. In fact, those components have been crafted with Material3 design specifications, so which makes the implementation much easier and simplifies the maintenance of the code. So this year, Todoist on Wear OS migrated to Material3 Expressive, and they share their experience in an Android blog post, which I invite you to read if you're curious learning more. And when it comes to implementing the Material3 redesign, they shared some quotes, such as, "The APIs work, and they're simple and intuitive." And this is exactly what we will be looking at today. Now, I'd like to walk you through some of the tips when migrating to Material3 to further delight your users while keep your code clean and maintainable. So we will look at scaffold, lists and ensuring that list items are not clipped, how to easily enable shape morphing on Compose components, how to implement the iconic Material3 Edge button, and finally, what is dynamic theming and how to enable it. All right, as with many Compose apps, let's start with Scaffold. Scaffold on Wear OS is different from the Scaffold you may be familiar with your phone app. In Compose, you have a scaffold that accepts several composables as parameters. Among these, we find the top bar at the top, the bottom bar, and the floating action button at the bottom right corner of the screen. Now, going on Wear OS, Scaffold is made of two components. The first one is called App Scaffold, which allows static screen elements such as the time text to remain visible during in-app transitions. Think about when you swipe between screens. And App Scaffold is also the place where you put the swipe dismissible navhost for navigation. And then there is a screen scaffold, which is a second component you use for implementing scaffold on Wear OS. The screen scaffold displays the scroll indicator at the center end of the screen by default and coordinate the showing and hiding of the time text and the scroll indicator when interacting with the screen. If you were using the Horologist project, which is an open source project we built for helping developers to develop on Wear OS, you should be already familiar with this pattern and transitioning to Material3 scaffold components should be very easy. Just be aware that if you're migrating to Material3, you should only be using the scaffold from Material3 and do not mix with the Orologist ones. So let's look at screen scaffold in detail. So the screen scaffold holds the scroll state, which allows UI components such as the scroll indicator and the time text to automatically react to the user scrolling action. For example, the scrolling indicator you see on the right of the screen indicates where you are in the list, and you don't need to add any additional code to implement this. This is done by the screen scaffold for you. And similarly for the time text, where it fades away by scrolling, and again, this effect is managed by screen scaffold. The screen scaffold also holds the content padding, which is super important because it's used to apply padding around the main body content of the screen. So the screen scaffold provides the content padding value to its content as padding values object, and is a very best practice for your content, especially if you have lists, to consume this padding. So to make sure that elements are not clipped when using different watch screen sizes, we advise to use Orologists for easily calculating padding. This is consistent with the guidance we gave while we were in 1.4. So now in 1.5 version of Compose for Wear OS, we still advise to do that. The alternative is that you implement the padding yourself. But the good news is that we are looking to add its support via the library in version 1.6, which is coming next year. So then let's take a look at lists. On previous version of Compose for Wear OS, we advised to use Scaly lazy column. Why this list still works with Material3? We have now a new list called Transforming Lazy Column that we recommend to use for enhanced features, such as more dynamic and eye-catching motion. And my colleague Artemi is also going to give a talk later today about going deep in transforming lazy column. So let's look at understanding how transforming lazy column works. So transforming lazy column has a state parameter whose role is to be the single source of truth for the list scroll position and control its animations. So you typically share the same state object passed to the screen scaffold, which we looked at it earlier. So the scroll indicator and the time text component can react based on the user scrolling the list. The other parameter is content padding, similar to the screen scaffold. So this one specifies a padding around the entire list content, and you can use the content padding which we defined before for the screen scaffold. One of the most important features of transforming lazy column is that it allows you to apply transforming effects to elements of the screen as you approach the top and bottom of the screen, where I put those yellow arrows. Unlike scaling lazy column, transforming effects are not a default, are not automatic, and this basically allows you to customize more. For example, you can decide that maybe the first items of the list, such the list header of an icon, maybe you don't want to scale that, or you can choose how to customize how the scaling is applied. So transforming lazy column gives more flexibility than scaling lazy column. So for this transforming effect, the first step is to create a transformation spec, which defines a visual transformation on the items of the transforming lazy column. Here we are using a remember transformation spec, which creates a remember responsive transformation spec for us. Then for each item of the list, you can use the modifier transform height to calculate the changed height that will be passed into the transforming lazy scope based on the transformation spec. And then lastly, you set the transformation, creating a new surface transformation, And so this will cause the container or the component to dynamically change its content. So worth to mention that not all components have a transformation parameter. So for those that don't, such as the button group, you can use the graphic layer directly to create the transformation effect. So now let me talk a bit more about shape morphing, because this is a new feature in Material3 Expressive for Wear OS. So some components, such as buttons and group buttons, support shape morphing, and it is quite easy to enable it. So starting with the round components like icons, text, icon toggle, those all support variations that animate when pressed and checked. For example, in this example, notice how when you tap on the thumbs up button, the button morphs its shape. Basically, when you press it, the button morphs its shape. This one. So you can add shape morphing by simply using the animated shape method from icon button defaults. And so by simply adding this single line of code, you can get a fun shape morphing button like the one in this example. So today I'm not going to go through all the remaining components that support shape morphing with Compose for Wear OS. As earlier this year, we published a dedicated video just on the transformation of the morphing effect as part of the Delightful Compose series. So if you're interested in learning more, you can go and check it out. So now let me show you the new edge button, which features a curved edge bottom edge that perfectly complements the round display. So the edge button maximizes the available space, making it even easier to tap on it. And because it's at the bottom of the screen, it keeps the central area of the screen clear for the main content you want to display. Adding an edge button to your code cannot be simpler, but there are just a few things to remember as you do that. So Screen Scaffold has a slot for the edge button, and you can customize the size with 5 sizes available from extra small to extra large. And since the edge button is usually the last component of the screen, the system takes care of the bottom padding, so you don't need to specify all the code for the bottom content padding. But if you need to specify any padding between the last item before the edge button, you can use the edge button spacing parameter from the screen scaffold to do that. And that it's basically everything about how implementing the edge button. So now that we've gone through the basic building blocks for Wear apps in Material3, I also wanted to highlight a cool feature that you can easily enable in code. Dynamic themes is a feature that automatically adapts the watch interface colors to match the selected watch face, creating a more cohesive look by pulling colors from the watch face palette and applying it to the UI and tiles. And interactive elements such as buttons will change accordingly. So dynamic theming is a feature that allows your users to fully personalize their experience on the device. But we also understand if you prefer to stick to your color scheme and may not want to enable it. So I don't consider this feature as a must for migration to Material3 for your app. But still, I would invite you to at least try it out. So dynamic theming is not enabled by default on apps. So for enabling it, you need to modify the color scheme to use dynamic color scheme. Just be aware that the dynamic color scheme is only available on newest version of Wear OS, such as Wear OS 6. So the way you enable it, you specify the dynamic color scheme, but also add a default color scheme that you can build for devices that are not updated to the latest version. So you can find all the code that I showed today in the Where Compose starter sample on GitHub. This sample provides a good starting point if you are creating a new WebOS app or you want to migrate to Material3 Expressive. So after talking about why and how to migrate your app on Material3 Expressive, let's talk about tiles. So tiles on Where are fast, glanceable screens that provide quick access to information and key actions from various apps. Think of them as widgets specifically for your smartwatch. Material3 Expressive Design also lets designers and developers to create tiles that are both functional and visually engaging. And you can expect components such as the Edge button to be available in the Tiles Protolayout library, which is the library that we use to develop tiles on Wear OS. And we know many watch users likes to be active, so let's try to build a tile for easily starting a new workout. And I really want to focus on the Material3 updates from the Protolayout library, so I will not cover the overall setup of a tile service and some other boilerplate code that you will find anyway in our samples on GitHub. So tiles in Material3 have a slot-based layout called primary layout that provides developer with specific areas to place different types of content. So why we do that? Because this ensures that essential information and actions are always visible and well organized on the round display. So in this code sample, let's look at the main tree slot, the title slot, the main slot, and the bottom slot. Title slot is the easiest. It's just where you pass the title of the tile. And then you have the main slot, which is where the main content will be. Since we will be displaying 3 buttons, we will use a button group, a component layout that places its children in an horizontal sequence. And this behaves as a group which fills the entire available space to maximize the screen real estate, which of course is limited on the watch. So we place a button group item for every button that we want to display. And then we use the icon button component for showing an icon. And then finally, we work on the bottom slot. And we add the text edge button with a string and a clickable action. Now notice how the edge button has the round design that we looked at earlier for apps, so that the design is consistent between tiles and apps. One last thing to mention that it's new with Material3 and tiles is that the icon on top of the screen is now managed by the system, so you don't have to worry about that. So the way it works is that the system takes it from the manifest. So similarly to apps, also tiles support dynamic theming, but differently from apps. This is on a default for Wear OS, which helps making the tile carousel more consistent for tiles that uses Material3 Expressive. But if you prefer to disabling it for same reason we discussed about apps, the API allows you to do that. So we also have some improvements in the alpha version of Protolayout. For example, in the latest alpha, we introduced Material Scope with resource that you can use instead of Material Scope. And the benefit of this is automatic resource registration so that you can inline the image resource object in the layout itself. And then in the latest alpha, we added support for pending intent for any clickable Protolayout elements. So previously, to launch an activity from a tile, you needed to create a launch action, and this process had some limitations, such as requiring exporting your activities in the manifest. Now, if you start using instead pending intent, that is not required anymore. So when migrating to use pending intent, there are two things to call out. So make sure that the ID is unique among the pending intent clickables used within the same tile. And then it is highly recommended to provide a fallback action for backward compatibility, ensuring that the tile works well on devices that haven't been updated on the latest tile renderer. And so this can be either a launch action or a load action for this fallback. So finally, you can find the source code from this sample in our where samples repository, together with many other tiles samples. So to recap, today we covered how Material3 Expressive Design on Wear OS allows you to build experiences that are modern and delightful to users. You can use Compose for Wear OS to create apps that follow Material3 Expressive Design, and it is easy to do with the available components. Similarly, on tiles, the Protolayout library offers components and layout that are optimized for the round display and scale appropriately from small to large screen sizes designed with Material3 Expressive. So the best way to experience all of this is to try it out for yourself. Consult our documentation pages to find all the available resources, and from there also find our code labs and samples. So I hope this talk gave you some practical tips on how to build modern and expressive apps on Wear OS and to use Material3 Expressive Design. Thank you so much for attending.